My name is Greg Petersen. I work for TSI Incorporated in Shoreview, Minnesota. I graduated in 2013 from Ohio University with a Ph.D. in condensed matter physics. At TSI, I started off as an algorithm engineer, and I'm now leading a predictive modeling and simulation group. TSI is an international company that creates high-end sensors for aerosol particle detection, flow detection, pharmaceutical monitoring, environmental health and safety, and chemical speciation. The topic of this workshop is modern software design for physicists. It's a way of helping physics majors or physics graduate students learn modern design principles and help them achieve faster research goals.
So the main thing I think I learned from the workshop was that you should be able to write your code modularly and be able to, in the future, extend it in case you have any extra problems that you want to solve. The highlight from the workshop so far has been when we coded in front of everyone. We were sort of collaboratively putting code together, which I found really nice.
The more time we spend rewriting or reworking code is time that's lost trying to achieve more publications or trying to understand the problems of tomorrow. So the workshop focuses on a number of tools that are quite common in the industry for software engineers and software development. One is source control. It's how to manage your code, make sure that it stays stable, make sure you can work in a group efficiently. Another is object-oriented design. It's one of the main design patterns in the industry, and it focuses on allowing you to extend your code, making it more flexible, and in turn being able to change what you want to do as you learn more information while you're researching. I would say it benefits you when you're looking for a job outside of academics. It allows you to explore research options that you had not considered and therefore get to the meat of what you want to do a lot faster.
A highlight of this workshop, I think, is really seeing how versatile all the things we're doing are. We're really building a structure that can be implemented in many different ways and being able to inherit for a varying degree of problems that need to be solved. I can expand code in the future and developing a way that is expandable and not just solving one problem.
So as I went out into the industry and started developing with real software developers who have been in the industry for multiple years, I learned that there are many better ways I could have done and solved my problem, and I could have gotten it solved a lot faster. So I'd like to come back and share my lessons with the people who are attending the course. So if I can help them understand how to think about design, I think ultimately that will lead to improvements in their research.